Dorothy, like from like Wizard of Oz. I'm not as mean as you, Christian.
All right, so we're graphing systems of linear inequalities, and so we're graphing them the same way we graphed them individually, but now we have multiple of them, and we're looking for where the area that the solution occurs in basically is. So I've got x is greater than -1. So what is that line going to look like? Other one. Yeah, undefined slope at -1, and it's dotted. And it's shaded which direction? Over here? Okay, so it's shaded this way. Now the other one, x is less than 3, where's that?
Oh.
And which side am I shading on this one? You say left.
Whoa.
It's less than 3, so it's over here. So the cool thing about using like highlighters or something that are different colors, this is a section where I would definitely recommend multiple colors. If you're only using a pencil, you're probably going to have a harder time finding the solution when there's 4 lines that you're graphing. But what you need to do is you need to specify where the solution is, okay, so that it's very clear where it's occurring. And so the solution with the highlighters, it's where they're overlapped, okay, where you can see both colors at the same time. If you do it with like a pencil or something, you're going to need to like be drawing like lines somehow that show where it is. So I have a surplus of colors and markers and highlighters and whatever that you are more than welcome to use if you don't have them, but this is a section I would recommend you use colors. Let's see, 10, -x is greater than or equal to y, and -x plus y is greater than or equal to -5. So I need to get these to where I can graph them. Remember, even with these, if we divide or multiply by a negative, we still have to flip the inequality, which is going to change the direction that it's being shaded. So this one, the top one, is going to be y is less than or equal to -x. So I literally just flipped the whole thing just so that I have y on the left. Didn't have to do that, but. And then this other one, we need to add x over. So I've got y is greater than or equal to x minus 5. And now I just graph those lines. So the top one have an intercept of 0, got a negative slope, and are these going to be solid or dotted lines? Solid, so good enough. And then am I shading above or below for this one? Yep. Y is less than, so below. So that's going to be down here. And then for my other one, I've got an intercept at -5. And then a positive slope. This one's also solid. And is this one being shaded above or below? Above. So this one's being shaded up here. So my solution is over here in the overlap. All right, one more. It's going to get a little crazy. It's going to be 4 lines that we're graphing. If you can do 4, you can do any of them. All right, 24. X plus y is less than 5. X plus y is greater than negative 5. X minus y is less than 4. And x minus y is greater than negative 2.
So when you do these, will all the signs have to be the same in like the way that like they're all dotted or they're all like sung?
No, they do not. These happen to be, but they do not. All right, so this one is going to be y is less than negative x plus 5. This one is going to be y is greater than negative x minus 5. This one is going to be y is greater than x minus 4. And then y is less than x plus 2.
That was then again, just say it
How many times are you going to say that?
until you stop saying it.
Okay, I mean, you can infinitely say that. Freedom of speech, man.
Or we,
First, yeah.
I'll be judging that.
That's so funny.
You sound like
All right, so I'm going to do each of these obviously individually. These are all going to be dotted. Because you probably are going to end up using colors. If you accidentally do one solid that was supposed to be dotted, just like draw a little arrow to it and just write dotted, because obviously you can't, unless you have erasable pens, you can't erase a pen. So, all right, so we've got intercept at 5 and a negative slope. Oh, not that. Come back.
Go back.
So dotted line. And is this one being shaded above or below? Yep, below. It's less than, so down here. The next one, intercept at negative 5. And it's got a negative slope, but I'm going to go up and back because easier. All right, is this one shaded above or below? Above. Y is greater than, so it's above.
It's above.
All right, now intercept at, get this thing straight. Intercept at negative 4. Positive slope. And I'm guessing that's what you said is above. So then that's up here.
Too many for those things.
there's 20 dollars.
Really?
And then the last one. Wrong thing. All right, the last one, intercept at 2. Got a positive slope.
This is what you drew up on paper.
It's gonna like bleed through. So bad.
All right, so then this one is below, so it's down here. Huh?
I was gonna bring a red bandana today, right out. Like you would have thought it was gang affiliated.
I'm
Yeah,
s-
I mean, last time I brought a blue bandana one time. He told me to take it off because of gang affiliation. I was wearing it like at the headband, and like he called Miss Greer and was like, "Tell him to take it off."
The whole thing's practically a solution.
yeah.
That's
So it's
actually really funny. We
So-
should have a blue out. That'd be great.
Because they reckon blue.
all right. So this middle area here is the solution.
No, 'cause-
Not that you can see that says the word solution, but anyways, it says solution. So just make sure, because it is kind of mass chaos on paper, just make sure you label it. But all the colors overlapped in the middle, so, you know. It looks a little better than when I used to do it on paper. It kind of looked like that.
Wow. That's incredible.
So it's a little nicer having highlighters than just drawing lines in random directions, but anyways. All right, so your problems are 5, 13, 19, and 23.
This is 3-3 for